15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on another edition of the Space Nuts podcast. My name's Andrew Dunkley, and joining me as always is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hey, Andrew. How are you doing?
I am well. How are you?
I'm at large.
I'm living on Mars at the moment.
Oh, I thought you might be, yeah. Have you got red skies, pink skies?
Very red skies today. Yeah. We've got this massive wind. We've had some gusts well over 50 kilometres an hour today. And I know why this is happening, Fred. I washed my car on Sunday, so that's why this has happened. It is now covered in a layer of red dust, as is most of the city of Dubbo and most of the west of New South Wales, and it's yet another dust storm. And I think last time we recorded and we were having one, I said it was the worst one this season. Well, this is the worst one this season. They just seem to be getting worse. It's like this big red fog. And honestly, you could just look out and think you're standing on Mars to look at the sky. It's just like the photos I've seen from some of the probes on Mars. It's just incredible.
Next thing you know, Curiosity will be driving past.
Yeah, well, I think my car resembles Curiosity. I just have to slap a solar panel on top and all will be done. If you want to see some of my dust storm photos, by the way, you can follow me on Instagram, because I've got a bunch of photos on Instagram and a couple of little videos there if you want to take a look and see what I'm talking about. It's just extraordinary out here at the moment as we fight our way through one of the worst droughts in recorded history. So not a good time is being had by most of the residents of this part of the region. Anyway, we carry on, Fred. Inhaling dust, not my favourite thing, but I'll do my best. Today, we're looking at the European Space Agency, and they're dreaming big. They're thinking of looking into hibernation for long-haul space travel, I assume, which could be rather fascinating. I mean, it happens in nature, so why not do it to humans that we want to send into oblivion? We're also going to look at a crater impact in Australia. They've now revised the impact date. It was not 3 million years ago. It was last week. No, I don't know. And we've got questions about how Fred got started in his career. That was as a janitor. Light versus a black hole, who wins, and the power of solar winds. So we'll get into all those questions very, very soon. But let's talk about this idea that's been put forward that ESA is looking into about hibernation. It sounds like the stuff of science fiction, Fred.
It does, yeah. And, we've all seen science fiction movies where it's used, beginning, I guess, with 2001 A Space Odyssey. Although, I have to say, in some of the adventures of Dan Dare in the Eagle comic that I read in the 1950s, they had hibernation in that too, or as they called it there, suspended animation. The story of Dan Dare with the crypts and the fans and those terrible wars that they had. That was the way they got there to this star system light years away. The way the Earth people got there was by suspended animation. They went into what were called susper cells and were frozen and didn't remember anything until they woke up. So ESA, you're right, the European Space Agency has in fact put together a team that will look at the idea of hibernation as a feature of crewed space missions. They've got something called the Future Technology Advisory Panel, and I think that panel is probably the group that have put together the hibernation team. And so what they have been doing is hypothesizing an imaginary mission, basically, that would send 6 humans to Mars and bring them back within 5 years. Now, it's not clear to me from what I've read whether they're going to put people in suspended animation while they're on Mars, because that seems a bit pointless. And it certainly doesn't take 5 years to get to Mars. But it could be advantageous.
Well, it can if you work it out the wrong way.
If you're walking, yeah. So what just to clarify what we're talking about here, really the things that this panel has been looking at is how it would influence the design of the spacecraft rather than the technology of the hibernation itself, because we do not know whether we can put humans to sleep in this way. What you're doing is slowing down the metabolism so that you use far less oxygen, you use far less food, and that means that potentially your space mission can go a lot further away from the Earth than you could if you were using up all the resources on a long mission: food, water, oxygen, all the rest of it. So it's the technology and the influence of hibernation on the mission itself that has been studied by this group, rather than how you make people hibernate, because that starts. That it becomes an investigation into human physiologies. As one of the scientists, it's actually the leader of one of the European space science teams, said, we aim to build on this in the future by researching the brain pathways that are activated or blocked during initiation of hibernation, starting with animals and proceeding to people. That seems like a logical way to do it. Find out what the animals do and then see whether you can do the same sort of thing.
Well, they could study a toad that lives in the deserts of Australia, and it basically buries itself and encases itself in this mucus which solidifies, and they hibernate in there until it rains. And then they come up and then they get frisky and then they all go back down again. Hibernation in nature, I mean, some breeds of bear do it, is quite natural.
Yes.
But it doesn't stop the aging process, does it, Fred? I would imagine.
Well, I haven't hibernated, so I'm not sure.
I wasn't talking about you specifically.
Well, I thought you were for a minute.
No, I mean, if you were to do a long-haul trip in space under hibernation, you'd be giving up that period of your life, basically, because you'd be out of it. You'd be gone. It'd be like being in a coma.
I don't know that that's true. When your metabolism slows down, I think it essentially preserves you as in better shape than if you were active.
So it could extend your life.
Maybe so. Although there are funny things that happen at a cellular level, the shortening of telomeres and things of that sort that I don't know anything about. That kind of thing might be more fundamental than whether you're conscious or not. However, it's very interesting stuff. There's perhaps there's a quote that I can read from Robin Beesbrook, who's again part of ESA, and he has produced a statement on this. We worked on adjusting the architecture of the spacecraft, its logistics, protection against radiation, power consumption, and overall mission design. We looked at how an astronaut team could best be put into hibernation, what to do in case of emergencies, how to handle human safety, and even what impact hibernation would have on the psychology of the team. They clearly thought about many of the details of this.
I've thought of another one. Debunk this. Okay, you go into hibernation and you travel for however long. Because you haven't been moving, surely the muscle wastage would be more significant because you wouldn't be able to do your treadmill exercises or anything like that. That would have to be an issue. You'd have to have artificial gravity to try and preserve some of the muscular and skeletal structures.
I don't know that that's true either.
I put a lot of thought into that.
I know. I could tell. I could see the steam coming out.
It wasn't steam. That was red dust.
Red dust, of course. That's right. You don't have steam anymore. But it's all about. So I think the way that you induce hibernation is basically put your candidate I'd use the word carefully rather than victim, which is probably a better word, into a hypothermic state. You reduce their body temperature.
So everything stops, basically.
Yes, and I think everything stops. That's right, or at least slows down. It keeps going because if it stops, then you really are in serious trouble. But things slow down. So you and I think in this conversation have really revealed to the world at large that we know nothing whatsoever about this physiology of hibernation. But we can imagine what the inside of a spacecraft might look like, because one possibility of this is that. Actually, this is another piece of the research that came from this team. If you have hibernation, you actually reduce the mass of the spacecraft. In fact, by an amount amounting to 1/3 of the mass of the spacecraft, because you get rid of the need for a lot of space within the vehicle. You get rid of the need to store the consumables, the food, the oxygen, water, all of that sort of stuff. And they're suggesting that all you need is a soft pod that would let you sleep in your hibernation state, but would double as a cabin when you're awake, although it wouldn't be very big. It's very interesting stuff.
Oh, it's fascinating.
Yeah, and I think I think anybody who's interested in following it up further can very quickly find some of the information on this on the web.
But indeed, everything's on the web.
European Space Agency is in the lead apparently at the moment.
Yeah. All right. Lame joke of the week. Of course, another science fiction film where they portrayed hibernation was in Alien.
Yes.
So Ripley hibernated, believe it or not. Come on, that was bad.
To, with a name like that.
He doesn't get it. He doesn't watch science fiction.
Science fiction's rubbish, that's why.
Ripley's Believe It or Not? You didn't get that?
No.
Explain my jokes.
Yeah, well...
It's a TV series.
What's TV again?
Yeah, that's a good question. That is a good question.
No, I'm sorry. Science fiction jokes, by and large, Andrew, as you should know,
I'm going to hand out your email address and get everybody to send an explanation to you of that brilliant joke that I just told.
Well, all right, okay. Somewhere in the deepest bosom of my soul, I'm laughing at a joke that you've had to
Google Ripley's Believe It or Not, and you'll know what I'm talking about.
I won't even remember it, let alone Google it.
Ah, dear. Okay.
All right.
I think we've finished with hibernation.
Yeah. While you're tinkering around there, I'm going to Google it.
You're listening to Space Nuts with Andrew Dunkley and the good Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, before we get into the next topic and people are going, oh, he's going to bang on about Patreon and YouTube again. No, I'm not. I'm currently writing my next science fiction novel, which I know you're busting to read. But funny thing happened. I've reached a point in the story where I'm not real sure where to go. I've got these ideas in my head floating around, but I'm trying to figure out how to put them into the story so that they work. And 2 nights ago, I had a dream. Based on one of our discussions, which I can't reveal. I'll tell you off the air so that you're not wondering, but everyone else will have to wait and buy the book. But I had a revelation in my dream, and I woke up and I said to my wife, I just had a dream about how to finish my book.
She said, for goodness sake, go back to sleep, will you?
Yeah, it was 2 a.m. But that's just bizarre that my brain has been sort of, working in the background on this and has popped this thought into my head, which I'm going to go with. I think it's fabulous.
That sounds very good. It obviously means you've got some processes going on in there. There's stuff happening in some recess of your central processing unit.
It happens to me from time to time in my current job, my day job. I sometimes have a problem and I can't figure it out, such as, reconciling the bank statement, which is a nightmare every month. But sometimes when I've been stumped, I'll wake up in the middle of the night with the answer. It's really weird. I've had it happen to me many times. I don't know. I should be an astronaut. I don't know why. Maybe it's hibernation.
You sure you're not going to sleep while you're on the job at
Yeah,
work?
I do that too. It's happened many times.
Do you wake up with the answer then? Because if you did, you could always, if anybody chastised you for that, you could say, well, I'm just
thinking.
Problem. Yeah.
I'm trying to work things out.
Yeah, there's a sub-process running somewhere that I'm trying to...
Now fluff my pillow and leave. That's... Yeah, maybe I shouldn't have a pillow in my office.
No, that is actually a bad sign.
Yeah, it is a very bad sign. Now, let's talk about this interesting crater, a meteorite crater in Western Australia. It's at a site called Wolf Creek. It's called the Wolf Creek Crater, I assume. They have now revised the impact date, and I'm wondering how and why that happened. Fred?
Yes. That's what this story is about. Let me just say something with respect to the traditional owners of that land, because of course in Australia the whole country has its traditional owners, and the name for Wolf Creek Crater in the Jaru language is Kandimalal. I might be mispronouncing that, but Kandimalal is the Aboriginal name for that feature. Which is, it's always good to know. And names like Wolf Creek, clearly quite recent compared with some of these very, truly ancient indigenous names that we have for landmarks here in Australia.
Well, I suppose most people would connect Wolf Creek with the name of an Australian thriller movie about a cutthroat murderer, but it's got nothing to do with that.
I didn't see that either.
No, I haven't either. Doesn't.
Okay. just
not
before
science fiction, so it can't be any good.
Just before you try and make an in-joke about it, I'll just tell you you're wasting your time. Although
I've already figured that out today.
I did spend an interesting 15 seconds there exploring the Ripley's Believe It or Not website, and most of it I don't believe, I have to say. But at least they're asking. So, okay, so here is a really very spectacular and very well-preserved meteorite crater, actually almost in the middle of Australia. It's not far from the Northern Territory, Western Australia border. And it's big, too. It's, I think if I remember rightly, it's almost a kilometre in diameter, 892 metres. So a research team from the University of Wollongong, which is not very far from here in Sydney, it's just down the coast, led by a geochemist by the name of Tim Barrows. He and his team have basically analysed Wolf Creek to death, by which I mean they've done as much measurement as they possibly can on it, including the actual morphology of it, the dimensions. As I said, 892 metres average diameter, average depth 178 metres. But in fact, there's a layer of sand or dust on top of that brings the floor up to something like 50 metres below the boundary. So the age of the meteorite crater is one of these things that has been a contentious issue, and that's partly because it's really hard to date rock directly. You've got to use all kinds of subtle methods to do that. It's not like vegetation where you can use carbon-14 decay in order to date it. There's a very well-established decay rate for carbon-14. So they use two quite different isotopes. These are ones that do decay once their molten phase is finished. Beryllium-10 and aluminium-26. So they've looked at those isotopes, the way they decay, and then there's something called optically stimulated luminescence, which is a way of measuring the age of something by looking in detail at it's a very nice way to put it in the article that I was reading on this, which has actually come from Nature magazine. But if you have a crystal lattice of sand that has been melted by the blast, so that when it solidifies makes a crystal lattice, and then you can look at the the way the energy within those within the lattice structure has changed. This optically stimulated luminescence, I'm not explaining it very well, but that allows you to look at the decline in energy that is within the crystal lattice itself. And so they've basically taken these methods and established that the crater cannot be any older than 137,000 years. And I think that's less than half the value that was originally thought. 300,000 has been a typical estimated age for this crater, but they're reducing that by more than half. 137,000 years is the oldest it can be from those metrics that they've deduced, but it seems more likely that it was actually about 120,000 years ago. So much more recent than was thought, and maybe that actually explains why it's such a well-preserved and obvious crater. I haven't actually been to Wolf Creek, but having seen some of the images that you can find on the web, it does look like a most interesting place. Has a visitor centre and things of that sort too.
I was going to say, is that a town in the middle of it, or is?
No, I don't think it's a town, but there's a shack on the near side of it, which I think is the visitor centre. I think there's a campground as well somewhere near, because I saw some reports from people who've been camping there. It's
when you look at it, it is a classic impact crater. It is so well defined. It's quite extraordinary, really.
Very similar in appearance to the Meteor Crater in Arizona, the Barringer Crater.
Yes, that's famous, that one. Been in a lot of movies.
Yes, that's right. And I have visited the Barringer Crater. It's got higher sides. I think it was made by probably a bigger object. The interesting thing about this, though, is that the suggestion is, when you do the calculation for the amount of energy that was released by the object hitting the surface of the Earth for the Wolf Creek crater, the suggestion is that it was an object around about 15 meters across, moving at about 17 kilometers per second. Now, that is comparable in size and actually slower than the Chelyabinsk object, which hit the Earth in a place called Chelyabinsk in Russia back in, I think it's February 2013, and that broke up in the air. There were bits that landed on the ground. Actually, they plunked into a lake. They penetrated the ice on the lake and were found later. Biggest piece was about half a ton, I think. Yeah. So this must be a much more solid object. It makes me wonder whether it was an iron meteorite, 15 meters across. That would be a much denser object than the stony meteorites, and maybe that's why we got such a spectacular crater from it. This almost 1 kilometer diameter crater in Wolf Creek. Very interesting story and interesting stuff.
I suppose anything in the area at the time of impact would have been affected?
Yeah, there certainly would have been big consequences for it. They wouldn't have been global, they would have been local, but definitely there would have been loss of species and things of that sort. Maybe not. Loss of life, living organisms, rather than loss of species. I suspect species themselves wouldn't have been lost, but the animals would have been. So, yes, it would have been a spectacular explosion.
Indeed. The other way that they could have revised the date of the impact would be to find the piece of the meteorite that had the best before date on it, which would have said something to the effect of best before 1117 1881 BC.
You should send that into Ripley's Believe It or Not, Andrew.
They probably, yes, indeed. All right, moving along. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Now, Fred, without at all mentioning Patreon or YouTube or the Space Nuts shop, Didn't hear it from me. Let's go through some questions. And we will firstly, this is a sort of a bit of a homework thing. We did answered a question recently from Jared Van Royen, and he emailed me and said, because during the course of the conversation, in reading out his email, he said, dear Professor Fred Watson and Mr. Dunkley, and I said to you, I've always wanted to say this, Jared, that's my father's name. And Jared thought that Jared was my father's name. No, Mr. Dunkley is my father's name was where I was getting at. It was a pretty bad joke, just like most of mine. So hope that corrects the situation, Jared. Sorry about that. When I listened back to it, I thought, oh, yeah, I can see how you would have thought that. Episode 177, just in case you're wondering. Now, Jared has another question. He wants to know about how you got into your career and maybe share any potential, ideas for those who aspire to the same profession.
Yes, I'm happy to talk about that because there are many, many different ways to get into probably not just space science and astronomy, but any profession. And my route into it was a mixture between the kind of conventional route, and I'll explain what that is in a minute, and a rather roundabout route, which I'll also mention because that's the way I got into it. I have to say, right from the outset, dead set on becoming an astronomer or a space scientist. From the age of about 16, that was when I was very keen to do that as my grown-up job. Before that, actually, Andrew, I wanted to go into the Navy.
Really?
Yeah, I did, yeah. I wouldn't have survived in the Navy. But the common denominator between the two, and the bit that makes most sense, is the fact that in the Navy, at least in my imagination, you use telescopes. And in astronomy, you use telescopes as well. And I happen to like telescopes a lot.
You do. You've
I
written
did
a book
then,
about telescopes.
and I still do. That's right. So that was the theme. So I was very keen on the idea right from an early age. And the conventional way in which you become a researcher in science is, it's the standard method. You do well at school, you pass your exams, usually in physics, maths, sometimes things like chemistry as well. I did geography actually at school because I thought I was interested in planetary science, and geography was the nearest thing to that we had at school. Then you go to university and you get as good a degree as you can. Then you go back to university and you do a research degree, which normally is a PhD, a doctorate, although I put in a master's degree in between because I actually spent 2 years working in industry before I went back to university to do my master's degree. And that was actually, it was because, to be honest, this must not go beyond these four walls.
Okay. Won't tell anybody.
It was because I nearly failed my degree. I was hopeless at maths. And it was a particular kind of mathematics that I really didn't have any aptitude for. And I very nearly didn't get the degree, but in the end I did. But that, I'd kind of had a bit of enough of studying after that. So I went and joined a company that built, guess what, telescopes. In fact, they built some of the biggest telescopes in the world, and I worked for them for 2 years. Then went back to do my master's. I did all kinds of things to support myself while I was doing that, including giving guitar lessons and hanging out with Billy Connolly and Jerry Rafferty and folk like that to try
wonderful.
and a quid. They were up-and-coming young musicians then. All of that meant that I basically survived. And then, in fact, after that, I went round the houses again because I worked then for the Royal Greenwich Observatory doing work on the orbits of planets. In a division of the observatory called Her Majesty's Nautical Almanac Office, which was that was still there.
You Brits have a great way of naming things.
Yeah, we do, don't we? Well, I mean, it was founded in, what was it, 17... Would have been, it's probably in, I can't remember. It's the end of the 17th century. It would have been. the Nautical Almanac Office. Actually, not quite. It was in probably the 1750s, 60s, something like that. So yes, all very ancient stuff. And getting my doctorate, actually, I was very, very fortunate, because by then, this was when I was in my 30s, I moved to the Royal Observatory in Edinburgh to work on galaxies with an academic who was a very generous teacher, a man called Victor Klub. He actually is one of the two people who figured out that maybe the dinosaurs were wiped out by asteroid impact. He was very much involved in that in the 1970s. I didn't work with him on that. I worked on the movement of stars in our galaxy, and then came to Australia and began building instruments again. I built fibre optics instruments to utilize optical fibers to allow you to make to gather much more data on stars and galaxies. It's a technology that we still use, only in a much more sophisticated way than anything I put together, which was all together with sticky tape and glue and all kinds of things like that. But that's what got me my doctorate, my PhD, that work on these novel fiber optics instruments. So it was a slightly tortuous journey, but like many tortuous journeys, it kind of got me where I wanted to be. And I think to Jared, that's the bottom line. Don't give up on it. There were times when I thought, well, I'm just a failure in this. I'm never going to make it. And there were quite often times like that, actually. But in the end, you sort of get there. And I wouldn't worry if, there's no direct and obvious route into playing a role in space science and astronomy, even if it's working in communication of science. Sometimes you can do that through amateur astronomical societies. You can actually communicate astronomy in such a way that you become, well respected for that, and that often opens doors that let you go into other things. So I would always be open to opportunities. I'd, keep your enthusiasm. Don't worry if things don't look as though they're going very well. I've seen many people who've basically pulled themselves up by their bootlaces and almost made a career for themselves in attracting sponsorship to fund astronomy festivals and things of that sort. So it's got lots and lots of avenues into which you can go.
There you are, Professor Jared van Rooyen. We wish you well, and thanks for the question, and hope we sorted out the naming issue. Moving on, Fred, greetings from Ohio, USA, Bengal territory. Absolutely love the show. Had a question regarding black holes. Oh, we've never had one of those before. A black hole's gravity is so massive that it draws in light faster than the speed of light itself. Being that light has no mass, this doesn't break the laws of physics. When an object of mass enters the event horizon of a black hole, wouldn't that object be travelling faster than the speed of light, thus breaking the laws of physics? Or would the spaghettification begin at the point of the event horizon, breaking down mass into a unit of energy instead of mass, therefore complying with the laws of physics? I'm looking for a loophole here. Thanks in advance, Tim Henry. I love Tim's question. That's really well thought out.
It is. It is. And what the one issue that crops up kind of at the beginning of the question is that it's not true that light's drawn into a black hole faster than the speed of light, because that would break the laws of physics. Light basically in a vacuum travels at a constant speed, 300,000 kilometers per second. What happens when it gets into a gravitational field, though, is that its nature is changed. And for example, when light that's in the vicinity of the black hole or leaving the black hole, it would be highly redshifted. That means it's the waves are stretched to give you, as a result of something called the gravitational redshift, and eventually that stretching is so big that the light doesn't escape from the black hole at all.
And we saw that with the photograph. It was all in, we saw redshift in that picture, didn't we?
Yes, that's right. Yes, you did. Yeah, that was material. That was actually the material that was glowing.
Okay.
But there is the way black holes behave is very, very peculiar. But they don't accelerate light above the speed of light, they can't do that.
Okay. So I think that pretty well answers your question.
Well, the answer is I'm not sure what the loophole is, and I don't know that there is a loophole there.
No. So if it's not increasing the speed of light beyond the speed of light, then there is no issue.
That's right. Yeah, that's right.
Okay. Thank you, Tim. Hopefully you understood that. I didn't. Let's move on to our final question for this week from Michael Davidson. Hi, boys.
I like that.
I do too. Thanks for the podcast. Just wondering, how much power does solar wind have? There is enough power to remove an atmosphere from a planet's gravity and can be measured billions of miles away. Is there enough power to wiggle a flag on an unprotected moon? We do need to get a flag out there somehow. I think we had one on the moon, or still have one on the moon, do we not? I think it fell over. Michael, good question. How much power does the solar wind have, Fred?
There are 6 flags on the moon, one of which did fall over. That was the flag. Yeah.
And 2 golf balls.
Well, at least 2, yes, probably more. There's a few, all kinds of other odds and ends. The answer to the bit about does the solar wind have enough power to wiggle a flag on the moon, the answer is no. In fact, to all intents and purposes, the truth of the situation is what I was told 100 years ago at school was true, that space is a vacuum. Effectively, it is. The density of particles within space is very, very low. But the particles are there, and the solar wind is real, and you can see its effect very clearly with the aurora if you're up in the polar regions or down in the polar regions here in the southern hemisphere. That's caused by the solar wind interacting with the Earth's atmosphere, being accelerated by the Earth's magnetic field and interacting with the atmosphere. But the density is so low that in terms of power, putting up a wind turbine or something like that is not really going to be anything that would deliver useful energy. I'm just kind of making a translation here, because sometimes we talk about solar sails and light sails, and you might think these are driven along by the solar wind, but they're not. They're actually driven along by the radiation of the sun, the photons, the light from the sun, which impart momentum to the solar sail. So the solar wind itself would not be enough to drive along a solar sail to get useful results from it. So it's unlikely to wiggle a flag on our unprotected moon.
There you are.
Nice though it sounds.
It does sound nice, but never mind, Michael. But I hope that clears things up for you in regard to the solar wind and how powerful it is. Thank you. Yep.
Sorry, Andrew. Just before we leave that, so Michael's comment: there is enough power to remove an atmosphere from a planet's gravity. That's true. But there will be other effects as well. To thermal changes in the planet too, and of course you're dealing then with a very, very slow process. I was going to say that. Yeah, God, you know the answer. And the other part of it is planets are very big, so you've got a large area of solar wind to deal with as well. Indeed. So, yeah.
All right. Very good. Thank you, Michael, for your question. Thanks to everybody for their questions. We strangely enough have gone nearly a week without a fresh question. And I think I know why, because they're all answering each other's questions on the Space Nuts podcast group on Facebook. That's what I think's happening.
Does that mean we can retire? We can
maybe with our tens of dollars.
And maybe nobody would notice if we suddenly just weren't there anymore and they answered our questions between.
I think they would notice. Anyway, if you do have a question, of course, send it in. We do have a little bit of a backlog to finish off. What we're finding now is a lot of the questions have been answered because of other questions of a similar ilk. So we're tending to sort of go past them. So hope that doesn't upset anybody. But if you really want to know, certainly drop us a line via our website's the best way, because there's a little question panel down the bottom, bitesz.com/spacenuts, where coincidentally the Space Nuts shop is. Anyway, we'll leave it at that. Thank you, Fred, so much.
Thank you for having me, Andrew. It's always a pleasure to be on your show.
Oh, it's your show. It's your show, Fred.
On our show, yes.
It's our show.
Yeah.
All right, very good. Nice to talk to you. We'll catch up with you next week.
Yeah, it sounds great. Thanks, Andrew. Take care.
Professor Fred Watson, Astronomer-at-Large. And from me, Andrew Dunkley, thank you again for your support and your time, and we look forward to catching you next time on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.